afternoon, everyone. I welcome you back to doctorate class. Now let's see how we can solve this problem in a very simple way. In a model of the hydrogen atom, the energy levels shown by E subscript n are given by the formula En equal to minus R over n squared, where n is an integer and R is a constant. Determine the energy released in the transition from n equal to 4 to n equal to 2 in terms of R. Now this is talking about a tiny atom of hydrogen. Of course, atom is very small, we can see it. So we are still talking about the different positions inside the little thing. We can't even see. So how can a new learner imagine what is going on and be able to understand why they apply the formula and how it's going to apply the formula? For someone who understands what is going on, it's easy to just go in, substitute, and you have your answer. Now, one of the easiest things I try to do, tell my learners, is this. Scientists draw an atom as tiny as it is, as this, according to Niels-Bohr's model. So, according to Niels-Bohr's model, right, the tiny atom has a small portion at the center where the protons and the neutrons stay. That is the nucleus, right? And after that, there are empty spaces, just like a skyscraper, right? A long-story building. The first circle here is the first floor where electrons can stay. The second circle is the next floor, the second floor, where electrons can stay. The third circle is the next third story building, and the fourth circle is the fourth floor. And that is what they mean by n equal to 4, n equal to 2. So n equal to 4 means this last circle, the electrons there. N equal to 2 means the second circle, the electrons there. And scientists call these circles stable states. That means when these electrons are found within these circles, they don't lose energy, they are comfortable, they are relaxed. It's as if they've paid their amount of money required for them to occupy these rooms. First floor, second floor, third floor, fourth floor. Now, since they're all here, none of them are disturbed. They've paid. They have their energies, they stay there. Now, imagine you want the electron in level 1 to go to level 4. It doesn't have the energy to go here. You have to give it energy to move from level 1 to level 4. When it's going from level 1 to level 4, it doesn't lose any energy. Rather, it will absorb to go up. But the problem is when it gets to this fourth floor, because it's not the normal floor you usually stay. It's unhappy, it's unstable, it's disturbed. It will like, I want to give up this energy and go back to my house. Then there's going to be an emission. It will return from level 4 back to level 1. It absorbs to go from lower to higher. But to go from higher to lower, it will emit, it will give out, it will transmit, okay, according to the language used in this question. So they're asking us, when it goes from level 4 to level 1, how much energy does it give out? Definitely it's going to give out the same energy it took to go up. But right now, it's coming out as light, electromagnetic radiation. Now, this diagram beside here is the same as what I've drawn there. So the n equal to 1 is this one. This second line is the second circle. This third one is the third circle. And this is the fourth circle. So this is when the electron returns back to level 1. Light is given off. Now let's come over here and see how we can simply apply the formula and solve it. Okay. Now this is the formula they give. En equal equal to minus r over n squared. For a new learner, it's best you let the learner understand how to find energy when it is at n equal to 4. N equal to 4, just say n e4. It will be minus r over, since n is 4, 4 squared, which is minus r over 16. What about when it was at n equal to 2? It's e2 minus r over n is 2 now, so we put 2 squared, that is minus r over 4. Now that means if you were in 2, then they took you to 4, you must pay the change to come back to 2. So the difference in energy it have to give back so that it can return to its house is energy in 4 minus energy in 2. Now what is energy in 4 minus r over 16 minus, remember, difference in energy. Now what is energy in 2? Energy in 2 is minus r over 4. So the difference in energy is going to release to return home is minus r over 16. Minus minus will give you plus r over 4. Now remember, we're asked to find this value in terms of r, so we don't have the value of r. We don't need to substitute. So we have change in a equal to, take LCM of the denominator 16 and 14. The LCM will be 16. 16 divide this 16, we have 1. 1 times minus r plus 4. Divide the LCM 16 will give you 4. 4 times r is 4r. Now what do we have left? You are owing r, but you have 4r. So just take 1r from here, pay for the one you are owing. You have 3r remaining for you over 16. And this is the amount of energy that will be released as electromagnetic radiation when the electron moves from level 4 to level 2. But for someone that is used to energy quantization, you can just go straight from the beginning and say change in energy is equal to E4 minus E2. And this is minus r, since n, the formula is minus r over n squared. The first there is 4 squared minus r, minus r over 2 squared. This is minus r over 16 plus r over 4. So if you know you are used to the formula, this is where you're supposed to go straight and solve it. But for a new learner, it's good we break it down. They see how to find energy at the different levels and subtract. Thank you.